Hello everyone. So in this video, we're going to talk about iterations or iterating and functionals with base R and a package called Purrr. It has this nice hex sticker down here. Purrr is part of the tidyverse. So for the outline of these slides, we're going to first talk about the importance of iteration in data science. So why is it deemed necessary to talk about this here? This is going to feel probably the most like a programming course out of anything that we've done so far. And I'm sorry if that makes you feel uncomfortable, but I'm sure, I promise it won't be that bad. Okay, so we'll talk about the importance of iteration in data science, and then we'll talk about how base R deals with iteration. And so that's going to involve the basic loops and control structures that you know from any other programming language. Now, for this course, I do assume that you have taken some type of programming before. For instance, the Python course is a prerequisite for this. It might have been a while since you've done that, and so this might be new to you, or you might have to think back a while to bring back memories of what a for loop is, so on and so forth. And then we'll talk about base R functionals. So we don't know what a functional is yet. It's different than a function. That's not a typo. That is intentional. We'll talk about what functionals are and why they're so important to the R programming language. So how base R does it, and then Purrr, which is basically an improvement of base R functionals. And so in Purrr, we'll talk about a function called map, and then there's going to be a lot of variants to map, and then we'll talk about some other functions. There's only really one other function that I want to talk about that it's going to be useful, but there are tons of functions in the Purrr package. So first, why is iteration important for the stuff that we're going to do? So first, in the modeling part of this course, which is going to be near the end of this first course, because I want to give you a taste of what modeling is, and especially if you can only take this course, I'd kind of feel bad if you took a data science course and didn't do some modeling in it. But it's really important to every part. We've used iteration before. We've just never done it ourselves. The nice functions that we've used have done it behind the scenes. But it's also important to create concise and readable code that people are going to try to understand and use, hopefully. Part of that is the DRY principle, or the do not repeat yourself principle in coding. And so iteration helps us to do that, to not repeat ourselves. And iteration is a tool for reducing duplication when you need to do the same thing to multiple inputs. So that's just a basic definition of what iteration is. Okay, so there are two types of programming that kind of go along with iteration, and the first is called imperative programming, and that's what you're probably used to in other languages. Those are the loops, the looping structures, so a for, a while, so on and so forth. And then there's another paradigm of which R belongs to, which is functional programming. So R is a functional programming language, and so it uses what are called functionals, or these functionals have a prominent place in that language, and we'll talk about what that is. And in R, functional programming is preferred over imperative programming because R is a functional programming language. And so some of you who have more experience coding, you may come from a computer science background, this might be weird to you. Okay, for instance, I will never ever want you to write a for loop for any code that we ever do. Okay, so I know that's weird, and you might think that's ridiculous, but you'll see what I want you to do and what functionals are and how they sort of improve. Well, you might not think they improve, but I'll say they improve over regular loops. Okay, so let's talk about basic looping. So for those of you who have no idea what's going on, okay, or have sort of stowed away any sort of computer science programming memories way back, because it was too painful for you. We're going to bring those memories back to the front in just a very basic way. So suppose, here's my task. I want to square every element of a numeric vector. Okay, so in R, I've got a vector, and I want to square every element. So suppose, here's my vector. Okay, I created a vector of length 4. It's 1, 2, 3, and 4, and I want to square that. So that's not really a problem in R because R is so awesome, and it's facetiousness, but I think R is awesome. You can just do vector squared. Okay, so a lot of things in R are what's called vectorized. And so these sort of operations like plus, minus, there's a bunch of functions that are called vectorized, and they will do that to every element of that vector. So really, in R, we just need to say vector squared, and then I get each element squared in another vector. But suppose R wasn't so awesome. How would we do that in sort of an iteration way, not writing 4 separate lines of code where you subset each element and then just square that element and sort of put it back in the vector? Okay, that would be the repeating yourself way. How would you not do that? And the answer should be, of course, a for loop, okay? Or you may think, if you're more clever, you may think of a better way to do that, but a simple way to do it is a for loop. And so what do for loops in R look like? So here's like a prototype of the for loop. So if you actually in RStudio type for, it's going to give you a snippet option where if you hit tab or whatever on operating systems, I think it's always tab, it's going to give you this template. So it's going to template the for loop for you. And so in a for loop, you say what variable you're sort of looping over. So usually the convention is to use I. Okay, so for I in a vector. Okay, so this is sort of weird. Probably this is like R is probably playing fast and dangerous, or whatever the term is, with for loops. So it's definitely different than a C++ for loop or a Java for loop or any sort of for loop you've seen before. The vector doesn't need to be like 1 through whatever. It can really be anything. And you can for loop through anything. Here's how I would actually do the operation. So I'd make another vector. So to be good about it, R you can do some weird stuff in, so you don't necessarily have to do all these steps, but I've made another vector called square vec. Okay, I made it a vector. Its mode is numeric and its length is the length of the vector. Okay, that's not necessarily needed. Okay, it might seem weird, but you don't have to specify the length of a vector beforehand for a for loop to work. Okay, R is weird like that. If you are computer sciencey based, okay, and that would actually seem weird to you. You don't have to, but I did here. So anyway, I've got a square vec. Square vec is a vector, and then down in the for loop, you see I say for I in, and then I have the original vector, and then I use a function called seek along. Seek along is a nice function that's often used in a for loop, and seek along creates an integer vector of the same length as the vector you feed it. So it is going to say, when you'd run seek along vec, it would give you an integer vector 1, 2, 3, 4, and it would go on. So it deals with sort of the weird cases that might come up well. So it's often nice to use seek along there. So sorry about that. And then inside, I just loop over. I say square vec of I is equal to the original vector squared. So I think it's a fairly simple for loop. Hopefully you can remember, but that's how R does for loops. Okay, great. Other basic I say control flows here, but basic looping or control structures. If you don't know how many iterations you need, then you would use a while loop. And so there's the while loop. You put the condition that it needs to meet to keep going, or the condition that it needs to meet to stop in that condition place, goes along. And then there's also like the if-else type stuff, okay, that works with conditions. So that's ours. That's like the looping stuff. Every loop that you can think of probably is in R, because R is a programming language, even though it is a weird one compared to other ones. It has all these basic looping and control structures in it. Okay, so now, what is a functional? So we can improve on, or I'm saying that we can improve on for loops. You may not believe me yet, but we do that with functionals. So in R, for loops have a really bad rap. And so here's a quote from the sort of Bible of R, which is called Advanced R, and it's by Hadley Wickham. It's online for free, so if you really do like R and you really want to get into the sort of facets of this programming language, R you can with this book. It's free online, just like R for data science is. So he says a common use of functionals is as an alternative for for loops. For loops have a really bad rap in R because many people believe that they are slow. But the real downside of for loops is that they're very flexible. And I'll let you keep reading there. But if you read that, you get a good sense, or you'll see, hopefully I'll be able to show you, why functionals are better. Basically, they are less flexible than for loops, and thus they're sort of optimized for the task. So for loops are very flexible and great for general tasks, okay, because you can use a for loop to do anything as long as you're iterating over. But a functional is often made for a specific task. And if you make something for a very specific task, it better be pretty darn good for that task. So generally functionals are preferred over for loops. They might be faster, they might not, but they're probably also more readable than a for loop. So generally for loops are not that readable, so it's harder to tell what you're doing, but hopefully you'll see in these next few examples that functionals make it very easy to see what's going on. Okay, so in general, a functional, in the definition of a functional, it is a function that takes in a function as one of its arguments and outputs a vector, or it outputs something, okay? So it could be any type, but it inputs a function, it does something to whatever, and then it outputs a vector or a list or something like that, okay? So base R has a lot of these functionals, and they're often part of the what's called apply family. So apply is a common thing to call these functionals because you're applying a function to a list or something like that. So there are the main ones, although there are many more. There's apply, which is different from the other applies, and then there's lapply, sapply, and vapply. We'll only talk about a few of these. And then some other functionals that you would use in not the cases that we'll talk about, but you can numerically integrate in R with the integrate function. So you feed it a function and do something else. And then you can also do optimization in R. Okay, so like you can in many other languages, R has base support for optimizing. And that's called the optim function, But the ones that I want to talk about are apply, lapply, and sapply. Okay, so here you'll get a sense, hopefully, of what they're talking about, or what I was talking about when sort of saying that functionals are better than for loops. So, for instance, the apply function applies some function over matrix or array margins. Okay, so if I have a matrix, matrix is like a basic data type. In R, it is a matrix in the mathematical sense. And if I wanted to apply a function to the rows or columns, I'd use apply. So for instance, I have this matrix on the left that has 9 entries, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and I make this call. So I want to apply to the matrix, and then in the middle I have this 1, which doesn't make sense, but I want to apply sum to it. Now, the 1 in the middle tells apply which margin to apply the function over. Okay, 1 signifies rows. Okay, so I would apply the function over the rows. Okay, so and I'm going to apply sum. So at the end, I'm going to get 3 numbers. And those numbers are going to be 1 plus 2 plus 3. So applying sum to the first row of that matrix, applying sum to the second row, and applying sum to the third row. Okay, and so when you run apply, it gets you 6, 15, and 24. Okay, and 2 applies it over the columns. Okay, columns. So think about what that would look like. Again, a vector of 3, of length 3, and it's the sums of the columns. Okay, so the apply statement, the apply function, is very powerful, and it's used a lot in certain areas of statistics and data science. Okay, and then now the most popular functional in base R is lapply. Okay, lapply. Now, don't ever call it like Lapley. Okay, it's lapply. I had a friend in graduate school who just could not pronounce anything correctly, and he liked to call this Lapley. Don't do that. It's lapply. Okay, and the lapply stands for list in, list out. Okay, so it's always a list in. Okay, but the L stands for that it's going to be a list coming out. So, for instance, I want to apply to that regular vector. If you remember in the last slide, or a couple slides ago, it was 1, 2, 3, 4. Okay, I want to apply to it this thing. Now, this thing is called an anonymous function, or as some other people call it, a lambda expression. So someone corrected me that earlier in the course, and I had no idea what was going on, and so I misspoke. I know them as anonymous functions, but other people know them, or they are called commonly elsewhere, lambda expressions. So this is a anonymous function. Okay, I don't name it anything, but I write it out just like I would write any other function, a function of x, and then it's x squared. Okay, so I apply that function to the vector, and what I get out is a list. Okay, where it's squared, so just like we had before. So there's lapply. And so hopefully maybe you can see why these things are nice to read. Okay, you know when looking at lapply, once you know what lapply does, it applies a function to a list or a vector or whatever. Okay, and so there's no sort of guessing by looking at the for loop, seeing what comes out, especially if you need nested for loops, so on and so forth. Okay, so that's lapply. The other two, or the other one that I want to talk about is sapply. So this is maybe the second most famous functional in base R. Sapply is list in, and then the S stands for that it simplifies output. Okay, so that means it guesses output type. So if it can, it'll turn it into a vector. If not, it'll turn it into a list, or it could output a matrix. And so in that way, it's really flexible, but it's also kind of dangerous. Okay, so watch out. Now, I'm never going to make you use lapply or apply or sapply because they're base R, and we're going to learn Purrr functions instead because they are better in some sense. Okay, but sapply, if I do the same thing as I did with lapply, but use sapply, it now simplifies the output to a vector, which is nice in this sense, but may be sort of troublesome in other senses. Okay, So another example that may be more statistical in some nature is I make a tibble. Okay, so now I have a data frame or a tibble. So over sort of what looks like columns, okay, A, B, C, and D, they're just random normal numbers. Okay, so I have 10 numbers in each column, okay, and then I can say apply to the data frame mean, okay, and then it takes the mean of each of those columns. So that's a really nice function of functionals that you may not get with traditional looping structures. Okay, so those functionals, base R functionals, we aren't going to talk about them anymore. We're going to talk about Purrr. So Purrr is the package in the tidyverse that does functional programming tools, okay, for data analysis. Now, an interesting point is that in further iterations of the tidyverse, Purrr may be taken out of it because it doesn't really directly get at data science. Okay, it's tools for functional programming in R, and so it's a great, powerful package, but it may not be part of the tidyverse forever. So that's something to keep in mind a few years down the road. Okay, but anyway, Purrr is a package that does functional programming. Purrr functionals, so it's a package full of these functionals. They generally do the same things as the apply family that we just talked about, but they provide more consistency. And so consistency is in a couple of different things. Other functions that we don't see in base R are capital named capitally. So there's a capital MAP or capital MAP map function. We'll learn about a lowercase map here. Okay, but just as usual in the tidyverse, they have common naming structures and so on and so forth. So there'll be some consistency there. There'll be some consistency in how you give the functions your function that you want to apply and your data. So also naming consistency, argument consistency, and so on and so forth. And generally, Purrr is pretty fast at what it does. Okay, and something that we won't get to in this class is they also provide some functionals that don't exist in base R, but people want to use. Okay, and so that's not what we'll see in this course, but it is there. So this is the cheat sheet for Purrr. Okay, and so if you ever need to look, just look up if you ever are stuck and you want to like a quick refresher, look this up online or look here. This is only one side of the two-sided sheet, okay? But it's here to sort of remind you, give you a taste of what the cheat sheet looks like. Okay, so the map function is sort of the basic functional in Purrr, okay? And map is equal to lapply. Okay, so it's going to be list in, list out. And so if I have my function x squared, and then I apply that to 1 through 3 with lapply, that's what I get. Okay, if I do the same exact thing with map, I get the same thing. Okay, and with both of these, we can use it in our pipeline sort of programming type stuff that we're used to. So the pipe can be used here. Those three statements up there are equivalent. Okay, so that's map, but there are many variants of map. Okay, many variants of map. Two nice ones are map if and map at. Okay, so these are going to take, as you might guess, map if is going to take in some logical conditions, and then map at is you're going to tell it where you want to map and where you don't want to map. So for instance, I've got my function x squared, and then I make x, which is a list of 1, but then I replace the 2 that I had there before with an a and then 3. So of course, if I try to just use map on x, it's going to yell at me because I can't square an a. Okay, can't square an a character, and so we run into a problem. But of course, I could use map if. Okay, so it adds an extra argument, which is that logical type of thing. So it says only map if the thing in x is numeric, and so then it it correctly jumps over A. Okay, so map if, and then I can do the same thing with map at. I just tell it, do it to the first and the third thing, but not the second. So there's map if and map at. And then other common ones that you'll see are the other like general variants of map. Okay, each one is going to act like map, but has a specified output format. And so these are nice because they are specified, or they only work for certain types of things. So what are they? Map int, map double, map logical, and map character. And as you may surmise, map int is going to take in a list and then output an integer vector. Okay, and so if you try to use map int on something that doesn't output an integer vector, it's going to yell at you. So it's specialized in that type of way. Okay, and so that's nice to use because you know the output format already, and so it might be a little bit faster than map, and it's going to yell at you when things go wrong. So a nice thing in programming is that you want to write code that will tell you when it's wrong. And so these things will tell you if you have the wrong input or the wrong output is coming out. Okay, so then there's map int, creates an integer vector, and you can guess map double creates a numeric vector, map logical creates a logical vector, and map character creates a character vector. Okay, great. So those are sort of the map variants. Now, another thing that you've seen a lot, or that you've seen sometimes from me, but I haven't talked about, are Purrr anonymous functions. So Purrr, the package, has support for its own anonymous functions or lambda expressions. So the base R anonymous function looks like that. And it's basically no simpler than writing out the function itself, because you have to write function of x squared. So many people don't like this because it's really verbose and it doesn't really gain you anything, because you're going to have to write all of this type of stuff. So Purrr provides its own anonymous function syntax. And so the Purrr anonymous function looks like this. So it always starts off with a tilde, okay, and that starts the lambda expression or the anonymous function, okay, and then there's some like dot involved. The dot's the really important part, but you have tilde dot x squared. That's the same as saying that top anonymous function. Okay, and so instead of having to write out that whole anonymous function inside map or lapply or whatever and getting the result, I can just write tilde dot x squared and get the same result. So I think that's a really nice part of Purrr that you should use whenever you can. So there's going to be a bit of a learning curve, and it's going to look weird for some of you at first, but it's really powerful and can offer speed up in writing code. Okay. Unfortunately, it doesn't do great things for readability in code, which is something that I will always push for. Okay, so there is a downside, but I know Purrr anonymous functions, and so you can write them and I will understand them, which is really the important point here. Okay, so not only does it do a simple like dot x squared, which creates that, but it can also do multiple arguments. Okay, so dot x plus dot y after the tilde will create a 2-variable function, so on and so forth. Okay, so it has extensions that make it more powerful than even just the regular function that I showed you. Okay, now the last part, or the last function that I want to talk about for Purrr, is the rerun function. Okay, so this is sort of another type of thing that Purrr offers that's different than those mapping stuff. They all belong to the same sort of family. Rerun kind of works differently, at least in theory. The code underneath may be very similar, but it kind of does some different stuff. So As a setup, sometimes you may want to rerun an expression multiple times in whatever you're doing. So for me, I'm often interested in what's called a Monte Carlo simulation. So we'll talk about simulation in general as part of our modeling part of the course. But Monte Carlo simulation is where you do the same thing over and over and over again. You have some randomness involved, and so it's not like the same exact thing, but you do the same process over and over and over again, and then you see how it behaves. Okay, and that's a big part of statistics. And so that's what this rerun function does. Okay, so you're going to use rerun a lot in what we're going to do, especially in homework number 6. Okay, so here is a call to rerun. So the rerun function is very simple. Okay, you specify to it how many times you want to rerun the expression. Okay, so I say 3, and then you give it the expression. Now rerun can take in one thing, or it can take in a whole, like it can take in 10 lines of code, 100 lines of code. It doesn't matter. It's just rerunning an expression, whatever that expression is. So I could do a whole bunch of things inside that second argument. It doesn't need to be like a call to one function. But here it is rnorm3. So what that's doing is that's creating 3 observations from a normal distribution with mean 0, standard deviation 1. That's not really important, okay? Three random things, and rerun is going to do it 3 times. And so when you do that, it looks like that. Okay, so rerun is a really important function. Now, if you look up rerun in the tidyverse, it's in the sort of questioning life cycle, which they think that it's not really valuable, and someday it might be taken away in some sense. Okay, so just keep in mind that rerun, there are other ways to do rerun, but for now, we're going to use the rerun function. Okay, and so that's it for Purrr and iteration type stuff. So hopefully this helped and it wasn't too scary. Okay, I'll see you next time. Thanks.